Yeah, hi, this is Steve Delalia from EB Industries. I wanted to speak to you today a little bit about two different types of laser welding that we do. Actually, it's two different types of modes. One is called continuous wave, the other is called pulsed. I'm not going to discuss the different types of lasers like fiber or disc or YAG or CO2. Not going to get into that today, just about these two different modes that you can run on most lasers these days. So the one that has been more popular in our industry, and we've been doing this type of welding for the last 35 years, is called pulsed. The reason why that became so popular is it was a practical, cost-effective solution when we got involved with it. Now, these days, you have a lot more choices. But what we have found is that although people could say continuous wave is the way to go, I can tell you personally that we probably run about 85% of our work here still in the pulsed mode, and I'll tell you why in a minute. So let's start out with the difference between the two. In a pulse laser, let's just think of it as a series of overlapping spot welds. So if I took a single spot and I hit a foot pedal and a single instantaneous laser comes on for a fraction of a second, it would make a little dot, a little circle in the part, something like that. Okay, we actually do that type of welding. We call it spot welding, and we got different workstations to go around if we want to just tack parts or just hold them together. But if you take a series of these and you set up your machine at a certain frequency to make a series of overlapping spot welds, and if this was a butt joint down the middle, we could weld with it. We could weld seams with it. We could weld linear and rotary welds, and that's most of the type of work that we do around here. So there's some important things you have to consider. What's the spot size that you're welding? What's the frequency? Pretty much the time between these two. You know, how many hertz are we running this at? That's pretty much dictated by that time. And we find that it's very cost effective. One of the big advantages to this is I can control my frequency and my feed rate, meaning how quickly am I moving the table, my feed rate. We can control those things a little bit to get the proper amount of overlap. Also, if we want to keep a part cooler, we can run a little bit faster, and the other advantage is we can control each one of these pulses. Each one of these pulses is typically a square wave. So if I wanted to weld aluminum, which is very reflective, I might want to put what they call an enhanced leading edge, which means I want the power to be very high when I first turn it on, and it will cut through a reflective coating. So it's very effective for welding copper and aluminum and any reflective materials. The other big advantage to this is since the laser is not on all the time, let's say I continue with my enhanced pulse, since it's not on all the time, the part during this period, the machine is off, the laser is off, I should say, it's recharging. So the part's going to stay a lot cooler because although we have high peak power that could go up to, let's say, as high as 10 kilowatts, since this machine is off, the average power on this machine might only be 400 watts. And if the average power, meaning it's only instantaneously for very short periods going up to high peak power, the part's going to stay cooler. Because the more power you pump into a part, the hotter it's going to get. Okay? So that's a big advantage to this type of technology. For a 400 watt machine, you can get a lot of effective penetration out of it. And some of my engineers and operators, they say these machines have a lot of punch. What does that punch mean? It means it's going all the way up to 10 kilowatts for a fraction of a second. So, you know, while it's on. So it's almost like a very violent laser beam that goes into it for, you know, instantaneously, on and off, on, off, on, off. With the continuous wave, it's a whole different animal and a whole different way of welding. You don't have that high peak. We have 4 kilowatt machines that run in continuous wave mode, right? So we have 4 kilowatt. Now in this case, you turn your power on. Your average power, well, we're never shutting the beam off. So our average power here is going to be what? It's going to be 4 kilowatts. That's also going to be our peak power, okay? So now we're pumping 4 kilowatts into this. We can't get that high leading edge like we got to weld aluminum. So you can only go up to 4 kilowatts. That's all you're ever going to get out of a 4 kilowatt continuous wave machine. And so you're also going to notice, since the average power is 4 kilowatts, the part is going to get very hot. So what are you forced to do? You're forced to have a feed rate that is very fast. You got to keep the part cool, and you got to move, or it's going to get extremely hot. That is a disadvantage when you're welding a $100,000 part that goes into a $1 billion satellite, and you have to run at 100 inches per minute to keep it cool and to make sure it doesn't over penetrate. So in that case, when you're welding expensive parts like that, you might want to watch it, because you can destroy that $100,000 part very quickly if it, for whatever reason, it runs off a weld joint, there's a fixture problem, a programming problem, whatever. So we actually like running at slower speeds, because we're not running millions of pieces. We like to watch what we're doing. If there's a problem, we can shut off the laser immediately. Doesn't happen often, because rarely do we have any programming problems or fixture problems. But if you're a customer of ours, we don't want to use an excuse that this thing was running so quickly that we destroyed your part and there was nothing we could do about it. So that's what we find is the big advantage to the pulsed welding over continuous wave. The positive on continuous wave, if I am running millions of parts or hundreds of thousands of parts, and time is a factor, meaning the beam is on a lot and the loading is very simple for the operator, and I might need to run very quickly to make money. So I have the ability to do that. And this also uses what's called continuous wave, similar to electron beam welding, uses a keyhole technique, which you could Google what that is all about. But in short, when it first welds, the beam first goes on into a part, it sort of drills a hole into it. And what happens is you drag that hole, once the hole is drilled, you drag that hole, that keyhole, along the weld path, and it will constantly be filling it in with the molten area is constantly filling into that hole. And you just drag the hole along. It's a difficult thing to draw, but you can probably find diagrams online that will be helpful with it. The advantage of that is you can go very deep with this. So if you need to go deep and you need to go fast, we have the continuous wave as an option. We also do electron beam welding. So part of the service we provide to our customers is we're going to advise you. We're not going to push you into continuous wave, pulsed or electron beam welding based on that's the only equipment we have. We will tell you this is the best process to run your part, or we'll tell you none of those fit. You should go somewhere else and possibly get it brazed or TIG welded, because there are applications for those that type of welding. We just don't do it. We stick to what we're good at. This is what we're good at: pulsed welding, pulsed and continuous wave laser welding, and electron beam welding. We provide some other services. We do some 3D cutting, 3D welding, but that's our core business, is high energy welding. We know it well. We know it from a practical standpoint, and we'd love to apply it to your application. So please contact us if you have any further interest. Once again, I'm Steve Delalio, I'm president and owner here, and we'd love to discuss your application. We got application engineers that that live and breathe this stuff all day long, and we would love to discuss how we can help solve your manufacturing problems by, applying one of the technologies that we are experts in. All right, thank you. Have a great day. Bye.